Okay, so the lecture cut out early, and it cut out the part where I talked about the bottom of page 8, type 1 and type 2 errors. So I'm posting another video for the people who weren't in lecture. So these two histograms here show the sampling distribution of a test statistic when the null is true and when the alternative is true. And let's think about what this means. Let's put it in the context of some example, first of all. Let's say this was a lie detector test. So when the null is true, there'd be no lying. These are not liars. And here, when the alternative is true, liars. Okay, and let's say this test statistic measures some level of nervousness. People are usually nervous when they lie, like maybe their heart rate goes up, etc. They sweat more. So there's some test statistic that's a quantitative measurement of whether people are lying or not. So we have to decide, are they lying or are they not? So we have this, what's called the null cutoff here. That's what this is. So when people are telling the truth, they're not lying. Some of them are getting, usually most of them don't have much, most people are around here, but some people still get nervous. But we have to, even though they're not lying, and we draw the line, we cut, so the distribution looks like this when they're honest, and we draw the line somewhere, usually around 5%. So this right here, this little portion right here, are the honest people that we made a mistake about, that we're calling liars. We're rejecting their honesty, and we're going with the alternative that they're liars. And that is an error. So this is a type 1 error. And we usually set that around 5%, but that's arbitrary. We could make it, if we wanted to, we could adjust that. So that is C right there. Now, this same null cutoff, of course, we're measuring the same thing, this test, we're just deciding between, on this side of it, we're saying they're honest, on this side, we're saying they're liars. So when we decide this way, we're correct here. But if let's say we don't have enough evidence to say they're liars, and our test statistic lands here in this area, well, that's great for people who aren't lying, but what about, and it's great for these liars, because we're going to call them honest. We're going to make another type of mistake, a type 2 mistake. Because remember, this side we're saying they're telling the truth, this side we're saying they're lying. So this is the proportion of liars who are not going to get caught. And there's a lot of liars who don't get nervous. People who compulsively lie are very cool and would certainly fall. There's certainly a big error where there's where it can't pick up people that are lying here in this case. So this right here would be D. That would be the type 2 error, which is a false negative. All right? And the power of the test is the power to detect an effect when it's there. So the power to detect the liars. We want a high power test. If we want a really high power test, then what we're going to have to do, given that this is the only testing equipment we have, we're going to have to make our slider, our null cutoff, to increase the power. We'd have to move it down here, and that would decrease the type 2 error, but it would increase the type 1. So there's a trade-off here. Unless you can get a better detection system and move these two curves further apart, the best you can do is to adjust your null cutoff. That's the only thing you can do. And so if we decrease the probability of a type 1 error by sliding the null cutoff, changing the null cutoff to slide to the right, look what will happen to the pink area. That will increase. So decreasing one will increase the other. Hope everybody understands that. Okay, Now, let's look at the next two questions. And it says, a large randomized experiment is done to test the effectiveness of some drug. The researchers do a significance test and set the p-value at 4%. Okay? And so the null and the alternative are as follows. Now, when the null is true, what's the chance the researchers will make the wrong decision and decide the drug works when it really doesn't? Well, that's right up here, and this says we're setting that at 4%. But how about when the null is false and the drug really does work? What's the chance the researchers will correctly reject the null? So what's the chance? So, well, we really don't know because we haven't been given that information. We don't know what the alternative is. We don't know what the typical. You don't know where this is located. It could be way up here, in which case it would be very high powered. It could be way down here. We don't know. So we weren't given enough information. We'd have to be given the percentage, like we were before in some tests, the percentage of false negatives here. We'd have to be given that, not only the false positives, but the false negatives. Okay, so that's it, and that's good luck on your exam. Bye.